I think it's incredibly important for application developers to understand the infra. I think there's some potential future world where all of the infra is actually perfect and you can have these like mental abstractions. None of the blockchains are there. None of the blockchains are even close to there. Solana is definitely not there yet. And I think it's really important for application developers to understand how the chain works so you can build better applications that serve the users better.
This episode is brought to you by Access Protocol. Access Protocol is the best way to get access to premium crypto content without the ads, without the annoying subscriptions that are impossible to cancel. It's crypto native. It's here today. Go check them out. What's up, everybody? Welcome to another episode of Lightspeed. Today, we're joined by Eugene from Ellipses Labs. Eugene, welcome to the show.
Thanks for having me, guys.
Pumped to have you on. Eugene, I'm not going to lie, I think you are one of the smartest people in the Solana ecosystem. So I'm pumped to have you on, and there's a lot we could talk about. But the thing that I really want to focus on, at least at the beginning of this podcast, is your post that you put out about 2 weeks ago. You tweeted it, and the title was Solana local fee markets are not real. So I want to get to that because it's a bit controversial. And I think a good place to start would just be describing how transactions work on Solana. So like as a user, go to Jupiter, what happens between the time when I click submit a transaction and when it actually comes back on the UI and it says confirmed?
For sure, we can start there. Honestly, Mert might be a better person to answer this question than me, so feel free to jump in anytime. But as I understand it, Jupiter creates a transaction that goes to your Phantom wallet to get signed. When the user hits approve transaction, that goes off to Phantom's RPC. In theory, it could be any RPC, which forwards the transaction onto a validator, which then forwards a transaction to the leader. So the leader is whoever is currently elected in the proof of stake system to build the current block. And then there's a bunch of complexity inside the validator itself, inside the leader itself. But essentially, there's first this network layer, the quick layer that transactions go through, and there's some throttling that happens there. So if your transaction gets dropped, this is one place where it can get dropped. After it makes it through there, it goes into the scheduler, or internally it's called the banking stage. But think of this as like the block builder, the thing that takes transactions, orders them into a block, executes them, and then forwards them on to the rest of the network. And so the transaction gets queued for execution, and there's a lot of complexity here because the queuing is multi-threaded. And so there's another source of jitter here. And essentially you have multiple threads that are executing these transactions as they come in, scheduling and executing. And a transaction can get blocked if it is trying to access some state that another executing thread is currently using. So Solana has state access lists, which built into the transactions themselves. So at the time of transaction creation, the transaction specifies exactly which pieces of state it needs to read from and which pieces of state it needs to write from. And this allows for this parallel execution. It also allows for parallel fee markets, but those aren't really quite implemented yet in Solana.
Yeah, that was really helpful. So I have a few questions for me, but also the audience. So one, you said it's multi-threaded, which essentially means you can do like parallelization, correct? From what I understand, there's like 4 threads, and how you can think about it, at least easier for me, is thinking about like lanes of traffic, and you have 4 lanes, right? And that's like 4 threads. One question I just have at a high level is, why is it 4 threads? Like computers have multiple CPUs. Why is it limited to 4? Yeah, how did that number get picked?
That's probably a better question for Solana Labs, but I think my mental model for how a lot of the constants on Solana work today is some engineer like roughly arbitrarily picked it a couple of years ago, and just these numbers haven't really been revisited. They've worked okay up until today. If you wanted to have far more threads, there's some trade-offs you'll have to take into account. One, you might have a little bit more contention for these accounts that are getting locked. So you have a little bit more overhead managing this locking system, which is single threaded because you have like a single locks manager. And then you might also impose a higher requirement on the validators themselves, so higher hardware requirement, where instead of having needing 4 cores for execution, you might need more cores there. And it's like so there's 4 threads for, let's call them user transactions, and there's also 2 separate threads for vote transactions, which are regular transactions in Solana. So technically there's 6 threads, but for regular user transactions there's 4.
To maybe talk a bit more about how those numbers are picked, they are kind of arbitrary, right? Like basically there's 48 million compute units available, and that was picked because it was determined that that's kind of how much the machine can process to arrive at 400 millisecond block times. And so it's more like an empirical way of getting the number instead of like doing some complex math to arrive at the right number, which we can talk about why Solana does that versus Ethereum, maybe, which is on the other side of the spectrum there.
So you're talking about one block has 48 million compute units. An account can have up to 12 million compute units in that block. And that is what really is supposed to allow for local fee markets. And an example that people often use of this is if you have an NFT mint, that's not going to raise up the prices across the board for, say, another DeFi transaction. And that's something that would happen in Ethereum. You were saying, though, that that type of local fee markets doesn't really exist yet. What is the reason for that? Like, what is preventing those local fee markets from actually working today?
Sure. So they kind of work. They work in this probabilistic sense. And first, we have to get to this difference in block building between Solana and Ethereum. So on Ethereum, you have these blocks that are at a very high level comprised of these user transactions that have gone to the mempool. And then you can imagine the most naive, greedy block building algorithm is you sort the transactions in the mempool by gas. And then if there's too many transactions in there to fill up a block, then you just take the highest paying transactions. So you can imagine for 11.9 seconds of the block, these transactions are entering the mempool, and in the last 100 milliseconds, the block is built in this greedy way by the block builder. On Solana, it works quite differently, where the blocks are actually built continuously. So as transactions are coming in, before the 400 milliseconds of the slot are up, the leader is building and executing the block on the fly. And so there's a lot of places where you don't get these guarantees. So for example, on Ethereum, if I send in a transaction at the very end of the block that has a very, very high gas price set, I'm very likely to get into the block if the block builder is being greedy. And this is not necessarily the case on Solana. So for example, if the block has already reached its 48 million CUs, and then I try to add something to the end of the block that pays a ton to the validator, I'm still not going to get in because the block is already built, and I'm just going to make it into the next block instead. So you have this continuous block building, which means you lose some of the guarantees from discrete block building. I think there's just a ton of benefits you get from continuous block building, where you can get really fast pre-confirmations to the users that are not limited by the block time itself. I think that's one common misconception people have about Solana, where they think the fast pre-confirmations come from short block times. And the short block times do help because you get to confirmed and finalization a little bit quicker. But it's really the fact that you have continuous block building. So in theory, you can have a pre-confirmation that is as fast as one round trip between the client and the leader. Then when it comes to local fee marks, we have to go a little bit more into the implementation of the block builder. And just real quick, none of this is actually enshrined in consensus in the same way that an Ethereum block builder or Ethereum validator can propose any valid block. There is no like rule of consensus that says the blocks must contain the highest paying transactions. That's just an incentive that the block builder or the validator has. And this is also true on Solana. So as these transactions are coming in, they're getting queued, and there's a single priority fee that can be set on the transaction. And you can roughly imagine the way these blocks are getting built. So we have these like queues. Pretend there's like 4 queues for the 4 lanes of traffic, the 4 executing threads. And transactions get scheduled to get executed, and then sometimes they get blocked and they can't get executed and they go back into the queue. So one way that you can implement this queuing mechanism with the priority fee is sorting the queues by priority fee. Here you would have like a priority queue of transactions that's keyed by the the priority fee set. And so if you set a higher priority fee, you are more likely to get in. But it is still possible that if I send a transaction at the same time as you that is accessing the same accounts and I set a higher priority fee, you might still get in first because you might end up going into a better lane just by pure chance. And it's also possible that even if my transaction is seen first, at the time mine is going to get executed, it's blocked by this locking mechanism, and then it has to get requeued. And then maybe yours is coming in right after that. And by that time, the lock has been cleared. And so yours can go in first. The canonical example is you have some hot NFT mint happening, right? You have a hot NFT mint happening, and the behavior you want is if there's way more than 12 million CUs per block of demand to access that state, the price you need to get in, the priority fee you need to get in is going to be higher than for some other uncontested state. And this is true in some probabilistic sense because you're more likely to get blocked trying to access this high contention state. But you still have this like global block limit. And then there's no real notion of a market, right? These things are all in this, I don't want to call it an auction, but it's kind of like a first price greedy mechanism. And the user, when they're sending the transaction, they have no idea what priority fee to set to get in. And this is really not an issue when blocks are not contested, right? So, when the blocks are not full. And so this is sort of the regime that Solana has, the market regime that Solana has been in for more than a year, probably 2 years or so, where blocks are just like generally not full. And then with the recent spike in activity in the last couple of months, we've seen blocks that are full. We've seen accounts getting saturated by the per block 12 million CU limit. And now we see some of the downsides of this priority mechanism where because you have this first price mechanism, it's very difficult to know upfront when you're sending the transaction, what is the priority fee I need to set to get in? And there's a lot of inefficiencies here where you have this incentive to spam because of the jitter, and then you might be overpaying in terms of your priority to get in. What you really want to enable, and this is like what most users actually want, right? Especially when the fees are somewhere between like 1/100th of a cent and maybe a few cents or even like 10 cents. The user really just wants to say like, hey, get my transaction in as fast as possible and just like pay whatever the market gas is. And there's no mechanism for that on Solana today. Whereas with some sort of controller mechanism that will tell you in consensus, in protocol, hey, here's what we think the fee you need to set to get in is. In fact, it might be like minimum fee enforced by consensus that says, if you don't pay at least this much, you're definitely not going to get in. And then that number can modulate depending on what the demand is. That actually provides for a significantly better user experience. So today on Solana, when the blocks are full, we're seeing all the natural things you would expect to see from this first price mechanism where all these protocols and all these users and all these bots are seeing, oh, my transactions are not getting in, the users are unhappy. And so everyone is just like jacking up the priority fees kind of indiscriminately in this like highly uncoordinated way, very empirical way. And that leads to a lot of inefficiency in the system.
Yeah, and in Ethereum, we've seen EIP 1559, right, which is that like in consensus base fee that will go up as you have more, as the block's more saturated over time, and then it's more predictable to get the next transaction in. I actually, over the last few weeks, when Solana and just the ecosystem was kind of skyrocketing with attention, my Jupiter transactions were getting dropped. Is that, and I don't know if that was related to slippage, or are blocks at this point actually getting full enough where we're already having this problem where the fees are moving fast?
Did they show up on your wallet?
No.
The failed transactions?
That's a good question. Maybe some of them. I just know
there's a bunch of ways your Jupiter transaction will fail to get in. So I think what Mert is getting at is if you see a failed transaction land, that probably means your slippage was not set high enough. So like the market moved away from your trade before you were able to get into the block, but your transaction was still scheduled and executed and landed on the blockchain. And there's two main other ways your transaction is not going to get in, and these are just like very difficult to observe from the outside. You don't really know where your transaction failed. One of them could be at the priority fee level, where because the block is contested, or the account you're trying to touch is contested, and your priority fee was too low, you were never able to get in. So that means your transaction made it to the block builder, it made it to the scheduler, but it was never scheduled and included for execution because because you were just like never at the top of the queue. And then another way your transaction can fail to get in is getting throttled at the network layer, at the quick layer. And it's just impossible to tell from the outside which of those is happening.
That makes sense. I guess at a high level, what are the basic ways to fix some of this going forward for Solana?
Yeah, so the network layer, I believe, is the actual layer where most of the transactions are getting dropped today. This is from my conversations with like RPC providers and some of the Solana core team. And that I have very little visibility into. I wouldn't say I have any good ideas on how to address that. There's like this very general like rate limiting problem, which is pretty tough. There is some like economic incentives you can throw in there, but at the end of the day, that really is more of an engineering problem. And then on the scheduler layer itself and the fee mechanism itself, setting a floor price on the priority fee, I think will just like help a ton. And so there's a lot of ways you can do this. I think in my mind, there's 3 changes we can make that are pretty much purely additive. Like there's just not that much downside in terms of just like really helping us improve the user experience on Solana, really getting back to the fast inclusion and fast confirmation that users love. So first is on the base fee. When all the blocks are full, like in the last few days, just like all the blocks are not all, but like the vast majority of the blocks are full or very close to full. This suggests that the base fee itself is too low. And here you just need some sort of escalator mechanism on the base fee itself. Today it's set to constant 5,000 lamp ports per signature. Let's call it 0.03 of a cent per transaction. And this is just like much lower than the market clearing price today. And so you have this first price behavior with the priority fee, which again is this like probabilistic thing. So one easy thing we can do here is if you see many of the recent blocks are full, you jack up the base fee until the blocks are no longer full. So you have some sort of target utilization as well as a max utilization. This actually looks very, very similar to EIP 1559. But we don't even need to think of it as like related to what Ethereum has done. It's just like a basic controller mechanism where you have some, you have a limited resource. And when there's too much demand for the resource at the current price to include everybody, what you need to do is increase the price until you hit the market clearing price. The second thing we need to do is instead of making the base fee paid constant per transaction or constant per signature, it really ought to depend on the amount of compute that the transaction uses. So today, a Solana transaction can use up to 1.4 million compute units. And if you use 1.4 million compute units, your base fee is exactly the same as a transaction that only uses 10,000 compute units, even though the larger transaction is more expensive to the network, consumes more of the resources. So the base fee just really needs to have some component that is linear in the number of CUs used or compute units requested. I think that's pretty much a no-brainer as well. And then the more controversial piece is how do we actually price these write locks? How do we actually price the contested state? And here I think, again, we can just implement a pretty simple controller mechanism where you have instead of having like a global base fee or just a global base fee and a global priority fee, you have a global base fee. So this is the controller that is going to make sure that when the blocks are all full, we're going to jack up that fee. And then when the usage goes down, then we can lower the fee again. You also have a mechanism like that on each account. So if the Phoenix Sol USDC market is hitting its 12 million CU cap very, very frequently, we should just increase the price that's required to access this market with a similar controller mechanism. And there's a lot of details here, right, that we're hand waving away. Like, what is the shape of the controller mechanism? How do you communicate these price changes back to the users or back to the developers? But those are all like pretty tractable problems. They're more engineering problems. Figuring out like what is the right controller mechanism, how fast do you want to increase the prices? Maybe that actually depends on what type of account it is and what you expect the shape of the demand to look like. But these things are all really to improve the UX, where we have this constraining resource, right? It's block space is not unlimited, even though on Solana it's like kind of felt like it's unlimited for a long time. In this current market, we see, okay, it's not actually infinite. And the way you're able to include the most valuable transactions as determined by the users who are sending them is to increase the price and then decrease the price when your resources are no longer overutilized. So there's a lot of theory in controller design. But at a very high level, you just want to have some sort of mechanism in place where if the demand exceeds the supply, you increase the price. It's really not too complicated.
Yeah, well put. There's a lot of economic back pressure work that needs to go live. Another issue that I might add is that, and this is being fixed with 1.17, or at least an attempt at a fix, is that the compute units aren't actually estimated that accurately, right? It's kind of an arbitrary unit, what compute unit means. And so that's something to keep in mind.
Just
and then
on that, Mert, can you explain like why does that matter? Like, how does that actually function? So, like when a transaction is submitted, it has estimated compute units, correct? And if that's way off from what's actually used, why is that important?
Well, it's just like you're just misappropriating resources in a sense, right? Like it's a compute unit is just a resource. And if you don't estimate it properly, then you're not making the best possible use of the resources. That's just the simplest way to think about it, in my view. So I want to recap what Eugene said, and then maybe I'll tackle the very first part, which was most of the dropping of transactions, let's say, happens at the network layer, which is to say that so basically what happens is you have a transaction and then it keeps being forwarded, and then after some time the block hash that you have is invalid, and because it expires, and so as a result you just don't make it in. Pretty sure what's now going to happen is Labs has a new thing for capping unstaked connections, so public connections, which is to say that you'll need an RPC with staked connections to actually make or prioritize your transaction properly, or extend it. Because previously, I think that mechanism was buggy, such that the number of public connections that you have wasn't being throttled properly, and so the people with staked connections were not making it in as much as they should be, and so that's being fixed. But so that's actually like the quick stuff that went live, right? It's just not perfectly implemented right now, which is often the case. And so that's number one. And then, so Eugene, just to recap what you said, one is dynamic base fees in a sense. And then two is going to be, or the last thing you said was basically like adding some sort of economic consideration for adding write locks to an account, right? Because that's actually kind of like a vector right now that I'm not sure many people talk about. And then the second thing you said was
is having the base fee depend on CUs used or CUs.
Oh, yes. Because right now it's priced on signatures, which is a very, very naive way, let's say, of doing it, or optimistic, because they should be a bit more granular in how you price them. Okay.
Yeah. And so the existing fee model basically assumes this world where blocks tend to not be full. And so maybe you don't really need to incentivize lower CU usage, but now we're in a market regime where that's not the case, and a little bit more like deliberate pricing is important.
Did you see the scheduler fixes coming in 1.18 by any chance?
I haven't looked at them in detail. I think there is a lot of work that needs to be done on the scheduler, and it sounds like there's good people working on it. So that will at least reduce the amount of jitter in the scheduler. The example I was talking about before, where like if we both send the same transaction, it's unclear who's going to get in first, even if one of us is paying a higher priority fee. And so that should be good for reducing spam for sure. Because right now, if you're trying to get included early, there's this massive incentive to spam.
One thing I'd add on the transactions and the spam is, Eugene, you quoted in that article that at least as of January 2023, I think it's 53% of transactions that land in a block are failed transactions. And is that just because spam is essentially dominating the block space right now?
Yes. And so again, this is from January 2023. This is a number that was pulled by the Jito team when they were looking at what is actually happening on chain and why are there so many failed transactions. And yeah, most of them are spammed arbitrage transactions and spammed liquidation transactions. And because the fees are so low, it's actually a good strategy to spam from the arbitrager's perspective, where you want to get in really, really fast. And so the best way to do that is just send your transaction many times. And even if you send your transaction 100 times and one of them succeeds, 99 of them land and fail, and you still pay the fee for those 99, it's still profitable in expectation. But of course, it's like kind of a poor use of the block space. And what we would like to see is something where in the ideal world, you would have like one of these transactions land and it pays a pretty high amount, and then you don't waste like 99% of the block space on these failed transactions. What the searcher is trying to express is like, I'm willing to pay, say, like up to $1 to land this transaction that is worth $1.50 to me. And instead, the only thing they're allowed to do, or the way they express this preference, is by sending 100 transactions that are worth 1 cent apiece.
Yeah. Yeah. And the priority fees are supposed to fix that, right? But because of the jitter, because the scheduler not being optimized, it doesn't always matter right now because latency is still such a big deal.
Yes. Well, it's going to be a feature of a system that has continuous block building, where like getting in first is super important. It's going to be more important than your pricing. The alternative approach here is sort of what Jito has done, which is moving more from this continuous block building world to a discrete block building world.
My last question on this whole fee topic is just, what do you think about, I've seen Anatoly talk about this a bit, and how do you come up with the right base fee that doesn't push out certain types of transactions? Because you have DeFi competing against payments, competing against different industries. And the thing is, if you push up the base fee too high, it might get rid of spam, but it could also push out these other use cases. So I'm just curious how you think about that. Because like from a lizard brain level, when I think of, oh, there's local fee markets, there's 48 million compute units, and there's 4 threads. Well, if you have 4 accounts getting, fired at the same time, then those local fee markets go away. And then you're going to have these, these payment transactions be priced out. So what do you think about that?
So that's more of a global fee problem than a local fee problem. And at the end of the day, it really is just going to depend on how much economic incentive is there for these payment transactions versus for these other transactions that I think we're implicitly valuing as not as valuable as the other transactions to the network. I would push back on that assumption a little bit, where, if people are willing to pay for these 48 million CUs and they're willing to pay, some astronomical amount, the network should be including those and not including, a transaction where the sender has expressed a much lower propensity to pay. Otherwise, you end up taking on these pretty opinionated assumptions about the value of transactions, and it's like kind of unclear how you can do that in a neutral way. And at the end of the day, again, you still have this like finite supply of block space. And if the market clearing price is very high, like the whole point of increasing the fee is to price out some like the lower value transactions. And today it looks like those lower value transactions are going to be these like failed arbitrage transactions that really no one wants them. No one wants them to land. They just happen to land. And they happen to get sent as a byproduct of this like inefficient fee mechanism and inefficient scheduler. But at the end of the day, if there's like so much demand for the block space at a given price, you're going to end up in this world where if you keep the base fee low, you're just going to have these payment transactions not get in, or they get in with like some probability that's like pretty low. And I think that's just a significantly worse UX than, hey, when things are really congested, yeah, you have to pay like 5 cents to get your transaction in. You have to pay 10 cents to get your transaction in. You can wait and hope that the price goes down later. But I think that's a significantly better UX than what we have today, which is you're bidding this arbitrary priority fee. You don't really know what it means. You don't really know how to set it. And in fact, it has no like actual economic meaning. It's really an implementation detail of how the scheduler works today.
One thing I'll say before moving on, Garrett, is like the 4 threads thing. Again, just want to highlight that that's arbitrary. I think the design goal here is essentially get the software in such a state that all you need to do to improve performance is add more cores, right? That and that's a long way or a long path to get there. Obviously, Eugene's pointing out some very valid implementation details and maybe even some actual strategy details as well that need to be reworked. But like once those, let's say, hypothetically get solved, then if you're in a state where you can just keep adding more cores, that's kind of like what Toly's and vision is. You briefly mentioned searchers, and then we also briefly described Jito and how they kind of get around this idea of continuous block propagation by holding like these mini discrete auctions or blocks. Can you so let's for people, because we haven't actually covered MEV on the show before. So for our listeners who aren't going to be sophisticated traders, could you briefly describe what MEV is, how it differs on Solana from Ethereum, and just how it works in general? Like explain like I'm 5.
I can try to explain it to you like you're 20. So MEV at a very high level refers to how much value and the types of value that can be extracted by whoever has this monopoly power of organizing the block. So that's the leader for both, the leader of the block for both Ethereum and Solana. So you can run this default native block building algorithm, which on Ethereum would be you order all of the transactions in the mempool by gas, and then order in descending order, and then place them into the block until your block is full, and that roughly will like maximize the value for the validator. And on Solana, the way the native block builder works is via the scheduler mechanism that we've talked about. But you can imagine if you have some like infinitely intelligent, infinite computational power validator, there's a lot of other ways they can make money as well. For example, you see all of these trades that are made